data. -3, -7, -2, -5, -1, -3, 0, -1, 1, 1, 2, 3, 3, 5. Does this data appear to be linear? Why? Okay, in the word linear, I'm going to point out a root word. We'll do some English for a moment. What's the root of linear? Line. Does this make a line? It does, so it is linear. Any questions about that? Just plotting points. Okay, let's do the second one. What did you want to know? This appears to be linear. No, does not appear to be linear. Why not? Does not make a line, right? It makes something other than a line, right? Looks like it's a parabola or a plot. Okay, so today we're going to be looking at data and analyzing data. There are two different types of data, and you just need to know these words. You don't have to write everything down on this slide. But there are two different types of data. There's discrete data and there's continuous data. Discrete data is when you just have data points. If I took everyone in here's height and shoe size, that would be random data points. There wouldn't necessarily be anything in between, right? Everyone agree there's like you might wear a 6 and someone else might wear an 8. And there's not a 6.3, right? It's just 6, maybe 6.5. But that's what's called discrete data. Data that is not continuous. There's not places necessarily in between. Continuous data is data anywhere in a range. For example, if you charted a person's height from when they were born until they got to full height, do they skip any heights? Technically. Do they ever skip a height? No. I mean, you might not know it, but at some point they had to be, unless they got like extensions put in their legs or something, right? You're going to go up at a continuous rate. Does that make sense? So that's what's continuous data. And they have some other examples of continuous data. Time in a race, like if I start timing an 800-meter race, right, that's continuous data because there's a distance at every single time point, even as small a decimal as I want to get. There's a place you were at that time. A dog's weight, length of a leaf, lots more. So continuous data is data that we plot with a line or a curve. Discrete data is plotted with points. How many of you on the last slide really wanted to draw lines through that data? Like wanted to draw a line or a parabola or something? We have that urge anytime we see data that we think it must be continuous. And I just wanted to point out to you, there are certain sets of data that you can't draw lines through because that's not correct for those data points. So continuous data, you can draw a line through it. Discrete data, you can't. So discrete data looks like a scatter plot. Continuous data looks like a graph, a normal curve that you would see. The biggest difference is read data versus extending this data. These words don't come up very often. I just hear them occasionally. The first place I ever heard them was when my husband was in his business classes in college, but this textbook uses them. Extrapolation is an estimation of a value based on extending a known sequence of values or facts beyond the area that's currently known. So that would be if I took everyone in here's height and shoe size and then said, well, I can guess someone's shoe size based on their height, who's in Miss Escalante's class, or something like that. Taking it and extending it outside the data that I have. That's called extrapolation. Interpolation is an estimation of a value within the two known values. So staying within what you know, but picking a value in that data set. So say I know if I'm clocking someone running an 800-meter race, say I know where they were at time 0, I know where they were at time 1 minute, and I know where they were at time 2 minutes. If I took that and found out where they were at time 1.5 minutes, that's interpolation. If I took that and found out where they would be at 3 minutes, that's extrapolation. So everyone see how that works? If it's outside what I know, it's extrapolation. If it's inside what I know, it's interpolation. Sometimes you can extrapolate information from data accurately, and sometimes it doesn't make any sense at all. For example, if I'm doing an 800-meter race and and I know their times from 1 to 2 minutes. So, anyone in here a runner? Anyone? Would it make any sense for me to find something gauge soon at 10 minutes? And someone tell me why that doesn't make any sense at all. Anyone who knows an 800-meter race? Nobody takes 10 minutes to run 800 meters. So finding where they're at 10 minutes just doesn't make sense in the problem. So extrapolation wouldn't work for that. Where interpolation would work quite well, because you could probably, if you have a good runner, they're going to run at a pretty constant pace, so you could find out where they would be based on their speed. So it just depends on the data you have. Two more vocabulary words. This is the main thing of what we're going to be doing today, and it's using a calculator to model data and determining some things from that data. So if you don't have a calculator in your hand, get one. By the way, I want everyone to check your bag and check your locker. I'm still missing calculator number 22. I know you didn't take it on purpose. Please check and see if you have it. Bring it back if you do. That would be awesome. Still missing calculator number 22. The following table gives the retirement payment for a 62-year-old retiree with at least 21 years of service at a company. So how many years of service and then how much they get paid. Now I want to find a line that fits this data. What doing that will do is allow me to guess what kind of payments I would get at 28 years or 29 years or 30 years. So it will allow me to extrapolate something from the data, decide. So that's what a line of best fit is used for. We could do this by hand. How many of you have been in a science class where you did this by hand? I know I see my sophomore CAP students doing that all the time, where they find slopes between lines and then write a line. And we could do that, but we're going to have our calculator do it for us. You will want to write down some of these calculator steps as we go. So if you will, get your calculator out and go to Stat. There is a Stat button right in the middle under Delete. And push Edit. It brings up a list 1 and a list 2. I have some stuff in my list you may or may not. Listen very carefully to these instructions. Don't do this wrong. Go do the up arrow and get up on the push the clear button. Do not push delete, but push clear. It'll clear out your list 1. Don't push delete. It will completely delete the list. Completely. It will be gone. I can fix it, but I would rather not have to. So L1, clear L1, do out. We're going to put the data in L1 and L2. Someone push delete on L1. Okay, if you will, in L1, put the years of service. In L2, put the retirement payments. You're welcome. So in L1, put the years of service. In L2, put the retirement payments. I am doing that with you. I'm going to leave my calculator screen down so you can see the numbers. So if you haven't done this yet, in your notes, side note on your notes to tell you the calculator steps, say stat, edit, type in data. So that's what we've done so far. We've pushed stat, we've pushed edit, and we've typed in the data. When you get home, you might forget these steps, so write down what we're doing. If you do forget a step and you get home and you're lost, what could you do really quick? Watch the video really quick and pull it up and just watch the. You can fast forward them, right? So you can fast forward to the part you need, watch that part of the video, and then go on to do your homework. Does everyone have that data typed in L1 and L2? This asks me to find the line of best fit. So I'm going to do that in my calculator. Before I do, there's a piece of information that I want my calculator to tell me that if I don't change something, it won't tell me. There are 2 different ways to do it. I think we can get there through mode now. If you go to mode and down to the second page to where you see stat diagnostics, you will. However, if you're using yellow calculator, you'll have to do it every time you pick up a new yellow calculator, possibly. So if you have your own calculator, you'll only have to do it once. If you don't have your own calculator, you will want to write this in your notes on how to do it. Write it in your notes, turn it on. So go, you won't have. And again, you won't